Which two are broad categories of data stores commonly used by organizations? Select two answers. A. File stores, B. Object references, C. Databases, D. Metadata repositories, E. Index catalogs. The correct answers are A. File stores and C. Databases. Now let me explain. File stores are used to hold data in the form of documents, images, and other files. They are the simplest and most common way organizations manage unstructured data. For example, a company might use Azure Blob Storage or SharePoint to store invoices, reports, and marketing materials. Moreover, databases are designed to store structured and sometimes semi-structured data, which makes them ideal for querying and analysis. For instance, an online store may use a database to manage customer orders, inventory, and payment details. In contrast, object references are not data stores at all. Metadata repositories focus only on information about data, and index catalogs are mainly used to improve search rather than act as primary storage. Therefore, the broad categories organizations rely on most are file stores and databases. A logistics company has seen a dramatic increase in the amount of tracking data from its delivery fleet compared to 10 years ago. It invests in a platform that can collect, store, and analyze this data to improve routing efficiency and reduce costs. Why is this approach valuable in today's competitive environment? Select one answer. A. Data is more difficult to collect and store than in the past. B. Data is a valuable asset that can improve decision-making and profitability. C. Data collection is useful only for compliance purposes. D. Analyzing data is optional for maintaining competitiveness. The correct answer is B. Data is a valuable asset that can improve decision-making and profitability. Now let me explain. In today's competitive environment, data has become a vital business asset that drives both efficiency and growth. By analyzing delivery fleet tracking data, the logistics company can uncover the fastest routes, minimize fuel expenses, and ensure timely deliveries, which in turn improves customer satisfaction. Additionally, unlike the past, collecting and storing data is now easier and more cost-effective through cloud solutions, making option A incorrect. Moreover, businesses leverage data for far more than compliance, using it strategically to enhance operations and gain an advantage, which rules out option C. Finally, analyzing data is not optional in modern markets because competitors who rely on analytics gain a clear edge, meaning option D is not valid. Consequently, the true value lies in treating data as a powerful asset that fuels better decision-making and higher profitability. For each statement below, indicate whether the answer is true or false. The amount of data generated has decreased over the last few decades. False. Data is found in many structures and formats. True. Entities represent important concepts to an organization such as customers and products. True. Attributes are unrelated to entities. False. Now let me explain. The first statement is false because instead of decreasing, the amount of data generated has massively increased over the last few decades due to digital technologies and connected devices. Next, it is true that data exists in many structures and formats, ranging from structured tables and databases to semi-structured files like JSON and unstructured content like videos or documents. Furthermore, entities do represent important organizational concepts, such as customers, products, or suppliers, making the third statement true. Finally, the idea that attributes are unrelated to entities is false because attributes actually describe entities. For example, a customer entity may have attributes like name, email, and phone number. Therefore, the correct sequence is false, true, true, and false. For each file format, drag it to the appropriate description in the correct match column. Each item may be used once, more than once, or not at all. Stores structured data in plain text with fields separated by commas or other delimiters. Delimited text, CSV, TSV. Represents data in hierarchical name-value pairs using braces and brackets, JSON. Represents data using tags enclosed in angle brackets, XML. Stores data as raw binary for images, video, or application-specific files, binary large object, blob. A row-based optimized file format with JSON headers describing the data, Avro. A columnar-optimized format developed by Hortonworks for Apache Hive, ORC. A columnar-optimized format created by Cloudera and X for efficient nested data storage, Parquet. Now let me explain. CSV and TSV represent delimited text formats, where data is stored in plain text with fields separated by commas or tabs, often used for structured data like spreadsheets. Next, JSON uses braces and brackets to represent hierarchical data, making it popular for APIs and web applications. In contrast, XML represents data with angle bracket tags, commonly used in configuration files and information exchange. Binary large objects, or blobs, are used to store raw binary content, such as videos, images, or application-specific data. Avro is a row-based format that combines JSON headers with binary storage for efficiency. ORC, created by Hortonworks, is a columnar format built to optimize Hive performance. Finally, Parquet, developed by Cloudera and X, is also a columnar format, designed for nested data with excellent compression capabilities. Thus, each format has its unique purpose and usage. In human-readable formats, such as JSON or CSV, how are the bytes of binary data mapped to printable characters? Select one answer. A, through a compression algorithm. B, through an indexing footer. C, through a row group metadata structure. D, through a character encoding scheme such as ASCII or Unicode. The correct answer is D, through a character encoding scheme such as ASCII or Unicode. Here's why. Human-readable formats rely on encoding to turn binary values into printable characters that we can see and interpret. For instance, ASCII maps the binary sequence 01000001 to the letter A, while Unicode provides an even broader set of mappings for global characters. On the other hand, compression algorithms are designed to reduce file size, not to translate binary into readable text. Indexing footers, such as those found in ORC, store pointers for quick access, but don't handle binary to character mapping. Likewise, row group metadata structures, often used in Parquet files, describe data layout, but don't transform binary into text. That's why encoding schemes like ASCII and Unicode are essential for making formats such as JSON and CSV readable. For each statement below, indicate whether the answer is true or false. A relational database can be queried using SQL. True. A key-value database requires values to be in JSON format. False. A column family database stores tabular data with related columns grouped together. True. A graph database stores entities in a table with rows and columns. False. Let's break this down. Relational databases indeed use SQL, a standardized query language, which makes the first statement true. On the other hand, key-value databases don't require values to be in JSON. They can be in any format such as strings, numbers, or binary, so the second statement is false. Moving forward, column family databases, like Cassandra, organize data into rows with related columns grouped into families, making the third statement true. Finally, graph databases don't store entities in rows and columns. Instead, they use nodes to represent entities and edges to represent relationships, which means the last statement is false. The sequence is therefore true, false, true, and false. A retail system assigns each customer a unique ID. In the sales orders table, that ID appears alongside each order to indicate who placed it. What is this ID in the sales orders table called? Select one answer. A, primary key. B, document ID. C, node link. D, foreign key. The correct answer is D, foreign key. Here's the reasoning. In relational databases, a foreign key is used in one table to reference the primary key of another table. In this case, the customer ID is the primary key in the customer's table, but when it appears in the sales orders table, it acts as a foreign key to show which customer placed the order. By contrast, a primary key would only apply within the customer table itself as its unique identifier. A document ID belongs to document databases like MongoDB, not relational systems. Similarly, a node link is a concept used in graph databases to connect nodes, not in relational tables. That's why the ID in the sales orders table is correctly identified as a foreign key. Fill in the blanks by selecting the correct options from the drop-down menus. OLTP stands for Online Transactional Processing and is designed for high-volume workloads in which data records are created, retrieved, updated, and deleted while maintaining ACID properties. Here's the reasoning. OLTP, or Online Transactional Processing, refers to systems optimized for handling large numbers of short, interactive transactions every day. These transactions typically involve CRUD operations, create, retrieve, update, and delete, that ensure data is always current. To keep these transactions reliable, OLTP systems adhere to ACID properties: atomicity, consistency, isolation, and durability, which guarantee data integrity even when multiple users are accessing the system at the same time. For example, when you transfer money between bank accounts, OLTP ensures that the debit and credit either both complete or neither does, protecting against errors. This makes OLTP essential for real-time systems such as e-commerce, financial services, and airline reservations. For each analytical data store type, drag it to the appropriate boxes in the correct match column to match it against its description in the option column. Each item may be used once, more than once, or not at all. Stores large volumes of file-based data for analysis. Data Lake combines flexible file storage with relational query semantics. Data Lakehouse stores aggregated measures from fact tables for rapid query performance. OLAP model uses a relational schema optimized for read operations. Data Warehouse. Here's why. A data lake is designed to hold massive amounts of raw file-based data in any format, making it highly scalable for analytics. A data lakehouse blends this flexibility with the querying strengths of a data warehouse, allowing businesses to perform structured queries on data stored in files. Meanwhile, an OLAP model stores pre-aggregated measures across dimensions in fact tables, enabling rapid analytical queries, often used in dashboards and business intelligence tools. Finally, a data warehouse stores data in a relational schema optimized for queries and reporting, making it highly effective for structured, read-intensive workloads. Unused items include operational databases, which focus on transactional processing, and NoSQL databases, which are built for non-relational use cases rather than analytical OLAP or relational queries. A company wants to enable business users to quickly view total sales by region, city, or individual address. They want the results to be nearly instant and to allow drill down between different levels of detail. Which solution best meets this requirement? Select one answer. A. Data Lakehouse. B. Data Warehouse. C. OLAP model. D. Operational database. The correct answer is C. OLAP model. To understand why, OLAP models are specifically designed for fast analytical queries. They pre-aggregate data across different dimensions, such as region, city, or address, which makes it possible to deliver instant results and allow drill-down analysis. By contrast, a data lakehouse can combine file storage with relational querying, but does not inherently pre-aggregate data for fast drill-down. A data warehouse supports analytical queries, but often requires more processing time when users drill into multiple levels of detail. Finally, an operational database is focused on handling day-to-day transactions rather than delivering rapid, multi-level aggregations. That's why an OLAP model is the most effective solution for this scenario. Arrange the following steps in an analytical data processing workflow in the correct order. Instruction: drag and drop the items into the correct order, starting with the first step at the top. Operational data extracted, transformed, and loaded into a data lake. Data loaded into schema of tables in a data warehouse or lakehouse. Data aggregated into an OLAP model. Reports, visualizations, and dashboards generated. I will now explain. The workflow begins with operational data being extracted, transformed, and loaded into a data lake, which acts as the central storage for raw information. Next, that data is structured by loading it into schema tables within a data warehouse or lakehouse, making it easier to organize and query. After that, the data is aggregated into an OLAP model, which prepares it for fast, multi-dimensional analysis. Finally, once the data is ready, reports, visualizations, and dashboards are generated to provide meaningful insights. For example, a retail company might load sales transactions into a data lake, organize them into a warehouse, aggregate them into an OLAP cube for regional analysis, and then display the results in a dashboard for business managers. This step-by-step process ensures data is transformed from raw records into actionable insights. Which role is specifically described as enabling businesses to maximize the value of their data assets? Select one answer. A. Database administrator. B. Data engineer. C. Data analyst. D. Data architect. The correct answer is C. Data analyst. Here's why. A data analyst's primary responsibility is to transform raw data into actionable insights that organizations can use to make informed decisions. By uncovering patterns, trends, and opportunities, analysts directly help businesses maximize the value of their data assets. In contrast, a database administrator focuses on maintaining and securing databases, ensuring reliability rather than extracting business value. A data engineer builds and maintains the pipelines and infrastructure that move and process data, but their role is more technical than insight-driven. Meanwhile, a data architect designs the overall framework of data systems, ensuring scalability and structure, but the focus here is not on maximizing data's value for decision-making. That's why the role most directly tied to this responsibility is the data analyst. Which two services are primarily used by data engineers to build extract, transform, and load ETL pipelines? Select two answers. A. Azure Data Factory, B. Microsoft Purview, C. Azure Stream Analytics, D. Microsoft Fabric. The correct answers are A. Azure Data Factory, and D. Microsoft Fabric. Let's go through the reasoning. Azure Data Factory is a key service designed specifically for defining, scheduling, and orchestrating ETL pipelines. It allows data engineers to move and transform data efficiently between different sources and destinations. Similarly, Microsoft Fabric includes ETL capabilities as part of its unified analytics platform, making it another core tool for building and managing ETL workflows. On the other hand, Microsoft Purview is focused on governance, cataloging, and lineage tracking rather than ETL processing. Azure Stream Analytics, meanwhile, is specialized for real-time stream processing, not general-purpose ETL for batch data. Therefore, the services data engineers primarily rely on for ETL pipelines are Azure Data Factory and Microsoft Fabric. Fill in the blanks by selecting the correct options from the drop-down menus. Azure Database for MariaDB was created by the original developers of MySQL and offers compatibility with Oracle Database. Here's the explanation. MariaDB was developed by the same team that originally created MySQL, which makes it a natural continuation for organizations already familiar with that database system. Moreover, MariaDB provides compatibility with Oracle's SQL syntax and functions, making migrations and integrations easier for businesses that previously relied on Oracle. On the other hand, Apache Hive is a data warehouse built on Hadoop and unrelated to MariaDB. MongoDB is a NoSQL database and not part of this relational lineage. And Azure SQL VM is simply an Azure-hosted SQL Server instance, not tied to MariaDB's compatibility. This makes the correct selections the original developers of MySQL and Oracle Database. Which Azure service can output processed real-time data for direct visualization? Select one answer. A. Azure Stream Analytics, B. Azure Data Factory, C. Azure SQL Managed Instance, D. Microsoft Purview. The correct answer is A. Azure Stream Analytics. Here's the explanation. Azure Stream Analytics is designed specifically to process data streams in real time and then send the results directly to visualization tools, enabling dashboards and insights that update instantly. For example, IoT sensor data or live social media feeds can be processed and visualized in near real time using this service. In contrast, Azure Data Factory is used for ETL pipeline and batch data movement, not direct visualization. Azure SQL Managed Instance is a relational database for storing and querying structured data, but it isn't built for streaming scenarios. Finally, Microsoft Purview is focused on governance and cataloging, not visualization. Therefore, when the goal is real-time processed data visualization, Azure Stream Analytics is the best fit. Fill in the blanks by selecting the correct options from the drop-down menus. Microsoft Purview can track data lineage across multiple data sources and systems. Let's break it down. Data lineage refers to the ability to follow the journey of data, including where it originated, how it has been transformed, and where it flows across systems. This is crucial for compliance, auditing, and trust in data-driven decisions. Microsoft Purview enables organizations to track this lineage across multiple data sources and systems, giving a complete view of data movement across complex environments. By contrast, data encryption is a security measure, not a lineage tracker. A single database would be too limited, since Purview is designed for broad multi-system coverage. Similarly, application UIs are not the focus. Purview catalogs and governs data, not user interfaces. That's why the correct answer is data lineage across multiple data sources and systems. Azure Data Explorer offers what capability for log and telemetry data? Select one answer. A. Automatic data lineage tracking. B. Multi-model NoSQL storage. C. Data lakehouse analytics. D. High-performance querying. The correct answer is D. High-performance querying. Here's the reasoning. Azure Data Explorer is built to handle massive amounts of log and telemetry data, and its standout feature is the ability to run rapid, high-performance queries across this data. For example, a company monitoring thousands of IoT devices can use Azure Data Explorer to quickly detect anomalies or track usage patterns in real time. On the other hand, automatic data lineage tracking is provided by Microsoft Purview, not Data Explorer. Multi-model NoSQL storage is a capability of Cosmos DB, while Data Lakehouse Analytics is supported by Microsoft Fabric. That's why the right answer is high-performance querying, as it directly reflects Azure Data Explorer's core strength. For each SQL statement type, drag it to the appropriate boxes in the correct match column to match it against its description in the option column. Each item may be used once, more than once, or not at all. Creates a new object in the database. Create grants permission to a user or group. Grant retrieves rows from a table. Select removes an object from the database. Drop. Let's go through this step by step. The create statement is used when defining new database objects such as tables, views, or stored procedures. Grant assigns permissions to users or groups, giving them the ability to carry out specific actions within the database. Select retrieves rows from a table, often with filters or sorting applied, making it the most common query command. Drop permanently removes an object from the database, such as deleting a table entirely. Meanwhile, update, which modifies existing data, and deny, which prevents permissions, are not part of the matches here. So the correct set is create, grant, select, and drop. For each statement below, indicate whether the answer is true or false. The SQL standard was first published by ANSI in 1986. True. The delete statement can remove specific rows when used with a where clause. True. The update statement always changes all rows in a table, even if a where clause is specified. False. Transact SQL is the SQL dialect used by PostgreSQL. False. Here's the explanation. SQL was first standardized by ANSI in 1986, with ISO adopting it the following year, so the first statement is true. The delete statement, when paired with a where clause, removes only the rows that meet the condition, which makes the second statement true. However, the idea that update always changes all rows even when a where clause is specified is incorrect. In reality, update changes only those rows that meet the where condition, and without it, all rows are modified, so this statement is false. Lastly, Transact SQL, or T-SQL, is Microsoft's extension of SQL used in SQL Server, while PostgreSQL uses its own dialect called PG-SQL, making the final statement false. The correct sequence is true, true, false, false. For each Azure open source database service, drag it to the appropriate boxes in the correct match column to match it against its description in the option column. Each item may be used once, more than once, or not at all. Pass implementation of MySQL based on Community Edition. The correct match is Azure Database for MySQL. Pass implementation of MariaDB based on Community Edition. The correct match is Azure Database for MariaDB. Pass implementation of PostgreSQL with supported core extensions. The correct match is Azure Database for PostgreSQL. PostgreSQL deployment option with high customization and cost optimization controls. The correct match is Azure Database for PostgreSQL. Flexible server. Moving into the explanation, Azure Database for MySQL is a fully managed PaaS service built on the Community Edition, which provides high availability, scalability, and point-in-time restore for business continuity. In the same way, Azure Database for MariaDB is a managed service that extends the MariaDB Community Edition with built-in security and enterprise reliability. Additionally, Azure Database for PostgreSQL stands out for its extension support, which makes it suitable for advanced analytics and applications requiring complex queries. Lastly, Azure Database for PostgreSQL. Flexible Server offers organizations more deployment flexibility, including customization options and cost optimization features, making it ideal for workloads that need fine-grained control. This variety ensures businesses can select the database service that aligns best with their application needs and operational priorities. For each statement below, indicate whether the answer is true or false. MariaDB was created by the original developers of MySQL. The correct answer is true. PostgreSQL supports custom data types and geometric data. The correct answer is true. Azure Database for MySQL is based on the Enterprise Edition of MySQL. The correct answer is false. Azure Database for PostgreSQL Flexible Server provides fewer configuration options than the standard service. The correct answer is false. Now let's go through the explanation. MariaDB was indeed developed by the original creators of MySQL as an open-source fork, ensuring continuity after Oracle's acquisition of MySQL. Similarly, PostgreSQL is known for its extensibility, supporting advanced features like custom data types and geometric data, which allow handling of complex structures such as lines and polygons. However, Azure Database for MySQL is not built on the Enterprise Edition, but on the Community Edition, which offers high availability and scalability without requiring a proprietary version. Finally, the flexible server option for PostgreSQL actually provides more configuration control and cost optimization features compared to the standard deployment, making it a preferred choice for organizations seeking greater customization. Fill in the blanks by selecting the correct options from the drop-down menus. Azure Database for MySQL is based on the MySQL Community Edition, while Azure Database for PostgreSQL supports a core set of extensions and built-in high availability. Let's move on to the explanation. Azure Database for MySQL is built on the Community Edition, offering features like automated scaling, security, and backups, making it a reliable managed solution for MySQL workloads. On the other hand, Azure Database for PostgreSQL provides support for key extensions that extend its functionality and includes built-in high availability and automated backups, which are critical for enterprise reliability. By comparison, Azure Database for MariaDB is specific to MariaDB workloads, and Azure SQL Database is Microsoft's SQL Server-based offering, not an open-source relational system. Fill in the blanks by selecting the correct options from the drop-down menus. In Azure Database for MySQL, connection security can enforce firewall rules and optionally require SSL connections for added protection. Here's the explanation. Firewall rules restrict access by only allowing specific IP addresses, which means only approved sources can reach the database. Meanwhile, SSL connections add another layer of protection by encrypting the data traveling between the client and the server, ensuring sensitive information like passwords isn't exposed during transmission. By contrast, temporal tables are designed for storing historical data in MariaDB, and Query Store is used in Azure Database for PostgreSQL to monitor query performance. A database administrator wants to ensure that a user named user1 can read and modify data in a table named orders, but cannot delete any rows. Which SQL statement should they use? Select one answer. A. Grant all on orders to user1. B. Deny delete on orders to user1. C. Revoke delete on orders from user1. D. Grant select update on orders to user1. The correct answer is D. Grant select update on orders to user1. Now let's explain. Option D is correct because granting select and update allows user1 to read and update rows while preventing them from deleting data. However, option A would be incorrect since granting all provides every permission, including delete. Likewise, option B denies delete access but does not give the necessary read or update rights. Similarly, option C revokes delete only if it was granted before, but does not provide the permissions user1 actually needs. Therefore, the best choice is option D, which precisely meets the requirement. An organization has two databases. One spikes in usage during end-of-month payroll processing, and the other spikes during mid-month reporting. Which Azure SQL feature should they use to minimize costs? Select one answer. A. Azure SQL Managed Instance. B. Azure SQL Edge. C. SQL Server on Azure VMs. D. Elastic Pool. The correct answer is D. Elastic Pool. Here's why. Elastic Pool is designed to let multiple databases with varying workloads share the same resources, which makes it highly cost-efficient when usage patterns fluctuate at different times. In contrast, option A, Azure SQL Managed Instance, is meant for migrating full SQL Server instances but does not focus on resource pooling. Option B, Azure SQL Edge, targets IoT scenarios, not enterprise database workloads. Meanwhile, option C, SQL Server on Azure VMs, provides full control but lacks built-in resource sharing capabilities. Therefore, Elastic Pool is the best choice as it directly addresses the need for cost optimization when databases peak at different times. Which two capabilities are provided by Azure SQL Database Auditing? Select two answers. A. Directly blocking suspicious queries in real time. B. Maintaining regulatory compliance. C. Understanding database activity patterns. D. eliminating the need for other security monitoring tools. The correct answers are B, maintaining regulatory compliance, and C, understanding database activity patterns. Now let's explain. Azure SQL database auditing helps organizations meet industry and legal requirements, so it plays a key role in maintaining regulatory compliance. Additionally, it provides detailed logs that allow administrators to understand database activity patterns, including anomalies and potential violations. However, it does not directly block suspicious queries in real time. It only records them. Furthermore, it does not eliminate the need for other security monitoring tools, because auditing is meant to complement, not replace, a broader security strategy. Consequently, maintaining compliance and understanding activity are the two main capabilities supported by auditing. For the different Azure Blob storage types, drag them to match their fixed characteristics in the correct match column. Each item may be used once, more than once, or not at all. Stores discrete, large, binary objects that change infrequently. Block blob optimized for random read and write operations in fixed-size pages. Page blob supports adding blocks only at the end. Append blob, used for storing virtual disk storage for Azure VMs. Page blob, maximum capacity of just over 195 gigabytes. Append blob can contain up to 190.7 T. Block blob. Now let's explain. Block blobs are designed for storing large binary objects such as images, documents, or backup files that do not change frequently, and they can scale up to 190.7 terabytes. In contrast, page blobs are optimized for random read and write operations in fixed 512-byte pages, which is why they are the underlying storage type for Azure Virtual Machine disks. Append blobs, on the other hand, only allow adding blocks at the end, making them ideal for scenarios like logging, but their capacity is limited to just over 195 gigabytes. Therefore, block blobs handle massive capacity, page blobs serve VM disks and random access workloads, and append blobs are used for sequential write operations such as event logs. Fill in the blanks by selecting the correct options from the drop-down menus. In Azure Blob Storage, a page blob can hold up to 8 terabytes of data. Now let's explain. A page blob is structured in 512-byte pages, which makes it highly efficient for random read and write operations. This organization is why page blobs are commonly used for scenarios such as virtual hard disks in Azure virtual machines, where fast and direct access to specific parts of data is essential. Moreover, the maximum capacity of a single page blob is 8 terabytes, which is sufficient for large-scale storage needs without over-allocating resources. In contrast, block blobs can scale much larger, up to 109 terabytes, while append blobs are smaller, capped just above 195 gigabytes, and are intended for sequential data additions like logging. Therefore, page blobs strike the balance between speed and size, making them the preferred choice for VM disk storage in Azure. An IoT company stores sensor data that is queried frequently for the first 2 weeks after collection, but rarely after that. They want to minimize storage costs without losing the data. Which approach best fits their needs? Select one answer. A. Store data in hot tier permanently. B. Start in hot tier, then move to cool tier using lifecycle policy. C. Store data in archive tier immediately after creation. D. Use page blobs for all sensor data. The correct answer is B. Start in hot tier, then move to cool tier using lifecycle policy. Now let's go through the explanation. The hot tier is ideal at the beginning because it supports frequent and low latency access, which is necessary during the first 2 weeks when the data is actively queried. However, after that period, keeping the data in the hot tier would only add unnecessary costs. That is why the lifecycle policy is useful, as it automatically moves the data into the cool tier, which is optimized for infrequent access at a lower cost. By contrast, storing data permanently in the hot tier would be wasteful, while moving it straight to the archive tier would cause long retrieval delays, making it unsuitable for recent queries. Finally, page blobs are designed mainly for random access in scenarios like virtual machine disks, not for handling large sensor data streams. Therefore, the best approach is to start in the hot tier and then use lifecycle policy to transition into the cool tier. A development team wants to read and write blobs directly from their application code without using the Azure portal. Which option allows them to do this? Select one answer. A. Azure Data Box. B. Azure File Sync. C. Azure Blob Storage API. D. Azure Portal GUI. The correct answer is C. Azure Blob Storage API. Now let's go through the explanation. Azure Blob Storage API is the right choice because it enables applications to programmatically read and write blobs without depending on the portal. In contrast, Azure Data Box is meant for offline bulk data transfer, not real-time in-app blob access. Similarly, Azure File Sync focuses on synchronizing on-premises file servers with Azure Files, not blob storage. Additionally, the Azure Portal GUI is primarily for manual management, which is not suitable for automated or application-driven read and write operations. Therefore, the best approach for developers who want direct blob access from their code is to use the Azure Blob Storage API. For each statement below, indicate whether the answer is true or false. Azure Data Lake Storage Gen 2 is a separate service from Azure Storage with no integration. The answer is false. OneLake in Microsoft Fabric is built on Azure Data Lake Storage Gen 2. The answer is true. You can revert an Azure Storage account from hierarchical namespace back to flat namespace. The answer is false. Azure Data Lake Store Gen 1 supports both structured and unstructured data. The answer is true. Now, let's move to the explanation. Gen 2 is not a separate service, but rather integrated into Azure Storage, combining the scalability of blob storage with a hierarchical file system. Meanwhile, OneLake in Microsoft Fabric is indeed built on top of Azure Data Lake Storage Gen 2, making this statement true. However, upgrading to a hierarchical namespace is a one-way process, so reverting back to flat namespace is not possible, which makes that statement false. Finally, Azure Data Lake Store Gen 1 supports structured, semi-structured, and unstructured data, so that statement is true. Fill in the blanks by selecting the correct options from the drop-down menus. When creating a Data Lake Storage Gen 2 system, you can enable hierarchical namespace during storage account creation or by upgrading an existing account. Now let's move to the explanation. Hierarchical namespace is required in order to use Gen 2 features, and it can either be enabled at the time of creating the storage account or later by upgrading an existing one. Importantly, this upgrade is a one-way process, meaning once enabled, it cannot be reverted. On the other hand, deleting a container has no link to enabling Gen 2 features. Using Azure Monitor is strictly a monitoring service rather than a storage function, and rehydrating a blob is associated with retrieving data from the archive tier, not enabling Gen 2 capabilities. Which two characteristics describe the open and compatible benefit of OneLake? Select two answers. A. Stores data in Delta Parquet format. B. Requires proprietary APIs to access data. C. Built on Azure Data Lake Storage Gen 2. D. Only supports unstructured data. The correct answers are A. Stores data in Delta Parquet format, and C. Built on Azure Data Lake Storage Gen 2. Here's the explanation. OneLake stores data in Delta Parquet format, which is widely recognized in analytics and ensures optimized and efficient storage for big data workloads. In addition, it is built on Azure Data Lake Storage Gen 2, which means it inherits scalability, performance, and compatibility with existing APIs. On the other hand, requiring proprietary APIs is not correct because OneLake is designed to work with open standards, allowing broad tool integration without vendor lock-in. Similarly, saying it only supports unstructured data is wrong, since OneLake can handle structured, semi-structured, and unstructured data. Therefore, the open and compatible nature of OneLake is best reflected in its use of Delta Parquet format and its foundation on Azure Data Lake Storage Gen 2. For each statement below, indicate whether the answer is true or false. OneLake is automatically included with every Microsoft Fabric tenant. The correct answer is true. Before OneLake, organizations commonly created multiple data lakes for different groups. The correct answer is true. OneLake only supports structured data formats. The correct answer is false. Workspaces in OneLake promote collaboration but remove governance boundaries. The correct answer is false. Now let's go through the explanation. OneLake is automatically included with Microsoft Fabric, meaning every tenant gets it provisioned by default. Before OneLake, it was very common for organizations to create separate data lakes for different teams or business groups, which often led to data silos. However, it is incorrect to say that OneLake only supports structured data because it actually supports any file type, including structured, semi-structured, and unstructured data. Finally, while workspaces in OneLake are designed to promote collaboration across teams, they do not remove governance boundaries. Instead, governance rules remain in place to ensure proper security and compliance. Which two tools can be used to upload files to Azure File Storage? Select two answers: A, Microsoft Word, B, Azure Q Explorer, C, Azure Portal, D, A's Copy Utility. The correct answers are C, Azure Portal, and D, as Copy Utility. Now let's go through the explanation. The Azure Portal provides a graphical interface that allows you to upload files directly into Azure File Storage, making it user-friendly and accessible through a browser. In addition, the As Copy utility is a command line tool specifically designed to transfer data efficiently to Azure Storage, which is especially useful for large-scale uploads. On the other hand, Microsoft Word is simply a document editing tool and has no capability for uploading files to Azure. Similarly, Azure Q Explorer is used for managing Azure Q Storage, which deals with message queuing, not file uploads. Therefore, the correct tools for uploading files are the Azure Portal and the As Copy utility. A company needs to store customer records in Azure Table Storage. Each record includes a name, multiple phone numbers, and multiple addresses in a single row. Why is Azure Table Storage suitable for this scenario? Select one answer. A, it enforces strict schemas to keep all rows identical. B, it automatically creates foreign keys between customer records. C, it only allows a single fixed column set per table. D, it supports denormalized, just semi-structured rows that can store all entity data in one record. The correct answer is D. It supports denormalized, semi-structured rows that can store all entity data in one record. Now let's go through the explanation. Azure Table Storage is well suited here because it supports semi-structured data, meaning you can store flexible and variable length information, such as multiple phone numbers and addresses in one record, without breaking it into separate tables. By contrast, enforcing strict schemas is a feature of traditional relational databases, not table storage. Similarly, it does not create foreign keys automatically since relational constraints are not supported in this system. Furthermore, it does not restrict you to a single fixed column set per table, as the schema can vary across rows. Therefore, the ability to handle denormalized, semi-structured rows makes Azure Table Storage the best fit for this scenario. For each Azure Cosmos DB concept, drag it to the correct fixed description in the correct match column. Each item may be used once, more than once, or not at all. Highly scalable cloud database service for NoSQL data, Azure Cosmos DB, enables developers to use familiar data store programming semantics, APIs, uses indexes and partitioning for fast performance. Azure Cosmos DB allows globally distributed users to work with local replicas via multi-region writes. Multi-region writes automatically allocates container space and manages indexes. Azure Cosmos DB. Let's go through the explanation. Azure Cosmos DB is a fully managed NoSQL database service that automatically handles indexing, partitioning, and container space, making it highly scalable and efficient. Additionally, developers can interact with Cosmos DB through APIs that mimic familiar database programming models, so they don't need to learn a completely new system. Moreover, the multi-region writes feature allows users across the globe to work with local replicas, ensuring high availability and faster access times by reducing latency. On the other hand, Azure SQL Database and stored procedures belong to relational database systems and are not part of Cosmos DB's architectural design. Therefore, the correct mapping is Cosmos DB for scalability, APIs for programming semantics, and multi-region writes for global distribution. Fill in the blanks by selecting the correct options from the drop-down menus. In large-scale analytics, data ingestion and processing involves moving and transforming information from source systems, while analytical data models often pre-aggregate values to simplify reporting. Here's the explanation. Data ingestion and processing refers to the stage where raw data is extracted, transformed, and loaded from multiple sources, making it usable for analysis. For instance, customer transaction logs may be cleaned and structured before entering a data warehouse. On the other hand, analytical data models, such as OLAP cubes, are designed to organize and summarize data, often pre-aggregating values to simplify and speed up reporting. In contrast, data visualization only focuses on presenting results through charts and dashboards, Data lakehouse is a storage approach rather than a processing stage, and batch storage simply refers to storing data in chunks without modeling. Therefore, the correct answers are data ingestion and processing and analytical data models. For each statement below, indicate whether the answer is true or false. A conventional data warehouse uses a schema optimized for querying and analysis. True. Multi-dimensional models in a warehouse often support drill-up and drill-down operations. True. Visualization outputs can only be web-based dashboards. False. Printed reports and PowerPoint presentations are valid forms of data visualization. True. Now let's go through the explanation. Conventional warehouses are designed with schemas that optimize analytical query performance, making queries faster and more efficient. Additionally, multidimensional models, such as OLAP p-cubes, allow drill up and drill down, enabling users to view data at different levels of granularity. However, saying that visualization outputs can only be web-based dashboards is incorrect, because visualizations can also take the form of mobile reports, embedded visuals, and even static exports. Lastly, printed reports and PowerPoint presentations are indeed valid visualization formats, as they communicate insights just as effectively as interactive dashboards. Match each description to its correct technology or concept. Each item may be used once, more than once, or not at all. API for ingesting, processing, and outputting perpetual data streams in Spark. Spark structured streaming storage layer, adding transactional consistency and schema enforcement to data lakes. Delta Lake, table-like data structure used in Spark for batch and streaming queries. Data Frame, common real-time streaming source for Spark. Structured streaming, Kafka. Now, let's go through the explanation. Spark Structured Streaming is a Spark library designed to handle continuous ingestion and output of real-time data streams. Delta Lake builds on data lakes by providing transactional guarantees and schema enforcement, ensuring data reliability for both batch and streaming use cases. Data Frame is the fundamental table-like structure in Spark that supports queries for both batch and streaming analytics. Kafka is widely used as a real-time event streaming platform and integrates seamlessly with Spark Structured Streaming as a data source. Unused items include Azure Blob Storage, which is general-purpose storage and not designed as a streaming API, and OLTP databases, which are optimized for transactions rather than large-scale streaming analytics.